a little extra session on fractions. So I'm just going to go over the rules quickly. This is fractions with signed numbers, so it's going to be positive and negative fractions. We don't call them integers because they're not integers, so we just say signed numbers. So I'm going to start with a subtraction problem. The rules for addition and subtraction are the same. We are going to change everything we do right now in fractions, in math, to improper fractions. The reason for this is because when you're having negatives, it can get very confusing. So 5 times 5 is 25, plus 2 is 27. Fifths, negative. Subtraction. 1 times 4 is 4, plus 3 is 7 fourths. The rule for addition and subtraction is I have to have a common denominator. So the common denominator for these would be 20. 5 times 4 is 20, meaning I have to multiply 27 times 4 and get 108 for this numerator. Did you notice that I didn't forget the negative sign? You have to have that in there. 4 times 5 is 20. 7 times 5 is 35. Now I can make my big bar, put the 20 on the bottom, and write my problem on the top. Negative 108 minus 35. That is a regular integer problem. Add the opposite. So now I get negative 143 over 20. And remember, in 7th grade, you can leave that as an improper fraction. You don't have to change it to a mixed numeral. So these are the rules for addition and subtraction. Change to improper, common denominator. I really suggest you do this big bar and put your problem on the top. Okay, let's do another one. 3 1/4 plus negative 2 1/6. So again, my rule is always change to improper fractions. 3 times 4 is 12, plus 1 is 13. 2 times 6 is 12, plus 1 is 13. Do I need a common denominator? I do. I'm going to use 12, and I know some of you were thinking 24, and that would be okay, but you're going to have to reduce then. Try to find the smallest number that they'll both go into. What I do is I take the bigger number, 6, and I do its multiples. Does 4 go into 6? No. I go to the next one, 12. Does 4 go into 12? Yes. So that is my common denominator. 4 times 3 is 12. 13 times 3 is 39. 6 times 2 is 12. 13 times 2 is negative 26. I have 12 on the bottom, big long bar, and I do 39 plus negative 26. A positive and a negative added together means I have to subtract, so I get 13/12. Do you need to change it to a mixed number? No, you can leave it just like that. All right, let's do a multiplication and a division. Multiplication and division. So if I had 3 3/5 times 2 5/8, and this one was negative, I'm going to do 5 times 3 is 15 and 3 is 18 fifths times 2 times 8 is 16 times 5 is 30 eighths. Now, what I'm stressing with you this year is I want you to reduce this now. Do not do 18 times 30 because you're going to get a big number to have to deal with. You can reduce any top number or numerator with any bottom number or denominator. So I know that 5 goes into 5 once. 5 goes into 36. know that I can divide these both by 2. 2 goes into 8, 4. 2 goes into 18, 9. I can still reduce here. 2 goes into 4 twice. 2 goes into 6, 3. I cannot do 3 and 9 because they're both numerators. Now I multiply across. Negative 9 times 3. Negative 27 over 2. I don't have to change it to a mixed number. And one last problem, division. So division is just like multiplication in that you're going to change everything to an improper fraction. We don't need to do that here because we don't have mixed numbers. The rule for division is you change it to multiplication and you take the reciprocal of the second number. I tell you that little phrase, oh me, oh my, I don't know why. I flip the second guy and multiply. Can I reduce it? Oh yes I can. 16 goes into 16 once. 16 goes into 32 twice. 18 goes into 18 once. 18 goes into 36 twice. Negative 1. Oh, here, look. I can reduce this with this, and my answer is negative 1. Negative 1 times 1 is negative 1. 1 times 1 is 1, giving me negative 1.